So I'll fail on my project, but fail is just a chance to learn, right? That's right. So this is my Bluetooth module that I've been working with. I wanted to change the Bluetooth ID name, which means I need to write into this EEPROM right here. Let me show you what's going on with this. So there's a Bluetooth processor, the OVC3860, and it's got a data line, SIOD, that goes across to the EEPROM, to the data line on EEPROM. Clock line, SIOC, that goes over to SCL on the EEPROM. The data line is bidirectional, so data can come out of the processor into the EEPROM or out of the EEPROM into the processor. It's a memory. That's what you need, right? You need to be able to read or write to it. The data line is open collector, so you can daisy chain a bunch of these together. So open collector means is it can drive this line low, but it can't drive it high. So you have this pull-up resistor. So what happens is when the EEPROM needs to output a 0, it drives the line low, and you get the 0 across here. When the EEPROM needs to drive the line high, the data line high, it just doesn't drive it at all, and this 5K resistor pulls it up to VDD. So anyway, I wanted to hook up my FT232 board from SparkleFun here. So I connected the receive to the wired the receive over to the data line, transmit over the clock line. It doesn't matter really which one you do. And I just set up a bit bang mode, and so I would just cycle the transmit clock on and off while outputting or reading data back. And what I did was I figured if I reset this 3860 board, it should tri-state these lines. I don't think it did it because I wound up blowing up this part. So that's this part here. This one here. You can see the EEPROM is missing right there. So it wasn't a total fail because I pulled it off and soldered it onto soldered right there onto my proto board. And then I was able to read and write to it, get the program working without destroying any more parts. So it wasn't so bad. But the reason it failed is direct connecting these lines. If this 3860 is trying to drive a signal over here at the same time, say the clock line here, right? At the same time I'm trying to drive it, right? Then say if it's 0 and I'm driving a 1, then I got all this current flowing into the part. What I needed to do was add these current limiting series resistors here. It could be, since this is 5K, you want them under 5, really want them under 50 ohms so they don't, so you can still drive the signal low. I use some 30 ohm resistors. Tried it again on another board and I didn't blow anything up. So, and the reason that works is, right, so if it's driving this low and I'm driving 3.3 into this, with this 30 ohm resistor here I can only drive 10 milliamps across it. Where when it's driving without it, I can drive the full power of this device into here, and I think that's what blew it up.